PMOD's 3D tool allows surface and volume rendering of data from all modalities, as well as rendering of VOIs. A dedicated segmentation interface allows particular tissues to be extracted and the segments to be organized before rendering. Multimodality data from the same subject can be combined, including application of 4D textures to show tracer kinetics. Many data types require some pre-processing to improve the 3D rendering outcome. CT data benefits from masking of the animal bed and tubes used for anesthesia or monitoring. PET data, including hybrid data, should be resliced to the same matrix as the anatomical reference used, such as CT and MR, which can be readily achieved using the FuseIt tool. In this exercise, we will start with a simple rendering combining surface and volume rendering for a CT image, including a simple VOI. In this case, we will open the 3D rendering tool, and from the Bruker PCI database on the DB Load tab, we can select mouse 6, a xenograft FDG PET-CT example. At the bottom of the list of series shown on screen, the PET whole body and CT series are the originals, and to save time, we have already prepared cropped and masked versions, including a resliced version of the PET, to go on with this exercise. That cropping and masking process was achieved using the methods already shown in section 1. Select the CT whole body crop masked series, add and open. After loading, processing starts on the segmentation page. The image is displayed in the Input tab, top left. In the lower section, thresholding and other segmentation methods are available on the left, and either the image histogram or a list of segments prepared are shown on the right-hand side. CT is useful for an initial demonstration, as certain tissues can be readily segmented by finding voxels with values above a particular Hounsfield unit threshold. In this case, we can enter a threshold of 500 Hounsfield units and then click the orange segmentation button. The voxels above the threshold of 500 Hounsfield units are displayed on the current tab in the top right of screen. We can turn on the MIP so that we can see the overall effect of that voxel selection. If the threshold was correct for detection of the bones, the MIP should closely resemble the skeleton. In this case, that looks successful. We should then save this voxel selection for rendering using the green Add Segment button on the right-hand side. The selection is added to the Segments tab in the lower right. Select the entry on the Segments tab and then click Set Segments 3D Rendering Properties below that. In the Edit Segment dialog, the rendering type can be set using the radio buttons, the color set for surface renderings, and a name defined. The skeleton will be rendered as a surface in white, and the name skeleton can be entered. Click OK to close the Edit Segments dialog, and then use the Workflow button in the lower right, Render Selected, to create our first rendering. The resulting rendering can be rotated using the mouse, left click and drag, and zoomed using the mouse wheel. On the Scene tab, Views subtab, the background color can be adjusted. On the Scene tab Rotation subtab, rotating movies can be started and captured using the film strip icon seen before. During capture, a rotation of the image using left click and cursor movements can be captured as well. On the right-hand lateral taskbar, the capture icon allows 2D captures to be captured using the usual range of formats such as JPEG, TIFF, or direct copy to clipboard for use in PowerPoint. Additional renderings can be added to the scene. In this case, we can return to the Segmentation tab. To add a volume rendering of the soft tissue from this mouse, we can change the segmentation mode from threshold to in range, and we can enter thresholds of 0 and 500 ounce-filled units to try and segment soft tissue. Then we click Segmentation, and in the current tab on the right hand side we should see MIP representing whole body outline due to identifying all of the soft tissue within the animal. Again, we can add this segment to the segments list. Then we can select it and adjust its properties. In this case, we will select volume rendering, with the color table grey, and we will rename the segment soft tissue. To avoid overwriting our surface rendering of the skeleton, we should be sure to activate the append pin immediately left of the workflow button, and then we can proceed using render selected. The rendering is updated and shows the surface rendered skeleton and new soft tissue volume. The entries for the two segments are listed in the View tab on the top right. There we can select the VR soft tissue segment, and we see the volume properties in the lower right. We can adjust the display by adjusting the thresholds for the color transfer function. In this case, by dragging down the upper horizontal bar, we can add additional transparency. And following this, we might render a VOI highlighting some feature of our image. In that case, we can explore the image by rotating using the mouse. And our goal will be to locate the lesion on the right hand side of the chest. In the top right, we can then select the Input tab, and at the bottom right of this tab we can select a VOI to be rendered. At the moment, no volume of interest is selected, so we should use the load dialog to select one from the database. In this case, for mouse 6, we have a tumor VOI, which we can then set for rendering. And then from the workflow button, we can select render the VOI as a surface. Smoothing is unnecessary, so confirm the dialog. And after the short calculations, we see our VOI appear in the location of that lesion on the right hand side of the chest. A explore the rendering using the mouse, and then try capturing a rotating movie.